After completing qualitative analysis of organic compounds, this video now covers quantitative analysis of organic compounds. In qualitative analysis, the two things which were important were, first, the method for analysis of a particular element, and the second thing, associated reaction along with the formula of the compound formed. In quantitative analysis, we need to remember the method, its apparatus and working, and the corresponding formula to determine the percentage of that element present in the organic sample. So on that note, let's start with quantitative analysis of organic compounds. In quantitative analysis, we determine carbon and hydrogen together, and the method to determine them is Liebig's combustion method. In Liebig's combustion method, there is a long tube with an inlet for pure and dry oxygen. So the pure and dry oxygen is passed through this inlet, which then comes in contact with the organic sample placed in the platinum boat. The gases which are released from here are passed to the copper 2 oxide, that is cupric oxide pellets. And here the cupric oxide act as an oxidizing agent. The reactions which happen over here are carbon is oxidized with copper oxide to form carbon dioxide, and the copper oxide is reduced to Cu. So the CO2 gas is liberated, and the ratio in which they react is 1:2. Then in case of hydrogen, the 2 hydrogen is oxidized by copper oxide to form H2O, and once again copper oxide is reduced to Cu. So the output from this copper 2 oxide pellets is CO2 and H2O. Then they are passed through the U-shaped glass tubes containing anhydrous CaCl2 and KOH solution. So the water vapors are absorbed by anhydrous CaCl2, and the carbon dioxide, being an acidic oxide, is absorbed in KOH solution. So the predetermined weight of anhydrous CaCl2 after absorption of H2O will increase. So the difference in the weight before and after will give you the amount of H2O produced from this organic sample, and similarly the difference in the weight for this U-shaped glass tube will give you the weight of CO2, which relates with the weight of carbon in the organic sample. So that is the working of Liebig's combustion tube. So now let's see the calculation for determining the percentage of carbon and hydrogen. So in Liebig's combustion method, the carbon is analyzed with the help of carbon dioxide, and we know that in 1 mole of carbon dioxide, which is 44 grams, the amount of carbon present is 12 grams. So if I have WCO2 as the weight of CO2, which is absorbed in alkali, then the amount of carbon will be equal to, just cross multiply, 12 by 44 into W of CO2. Now this weight of carbon dioxide is obtained from the organic sample having a weight of WOS. So if I have 100 gram of the organic sample, then in this 100 gram, the amount of carbon will be simply expressed as percentage of carbon. So with this calculation, the percentage of carbon is analyzed by 12 upon 44 into W of CO2 by W of organic sample into 100. So this becomes the formula. On the same lines, we can calculate the percentage of hydrogen formula. So hydrogen is estimated in Liebig's combustion tube via water. So in water having a weight of 18 gram, the amount of hydrogen is 2 grams. So if I have WH2O as a weight of water absorbed in anhydrous CaCl2, then the amount of hydrogen would be 2 by 18 into W of H2O. Again, this weight of water is obtained from weight of the organic sample which was heated in platinum pot. So, if I have 100 gram of the organic sample, then in this 100 gram, the amount of hydrogen will be simply percentage of the hydrogen. So, from here, the percentage of hydrogen formula is 2 upon 18 into W of water upon W of organic sample into 100. So this is how percentage of carbon and hydrogen is estimated. So summarizing, the calculation for percentage of carbon is 12 by 44, which can be remembered as 12 gram of carbon in 44 gram of CO2 into the weight of CO2 upon weight of organic sample into 100. Similarly, the percentage of hydrogen could be remembered as 2 grams of hydrogen in 18 gram of water into the weight of water upon weight of organic sample into 100. Now let's have a look at an example related to the estimation of carbon and hydrogen. On complete combustion, 0.246 gram of an organic compound gave 0.198 gram of carbon dioxide and 0.1014 gram of water. Determine the percentage composition of carbon and hydrogen in the compound. So, to determine the percentage of carbon and hydrogen, what we require is weight of carbon dioxide, weight of water, and the weight of the organic sample. And then we have a direct formula to use. Based on the information given, the percentage of carbon would be found as 12 grams of carbon in 44 gram carbon dioxide into weight of carbon dioxide upon weight of organic sample into 100. On substitution of the values, we get carbon percentage as 21.95% and percentage of hydrogen is equal to 2 grams of hydrogen in 18 gram of water into weight of water upon weight of organic sample into 100. Again, on substitution of the values, we get percentage of hydrogen as 4.58%. Now moving to the estimation of halogens. So halogen is estimated by Carriers method. In fact, for halogens and sulfur, the method used is named as Carriers method. So in the Carriers method, we have a long tube which is having a sealed capillary at the top, and there is a small tube which contains the organic sample or the organic compound, and it is heated with fuming HNO3 and AgNO3. So it's a simple arrangement of a long tube of 50 centimeter height and 2 centimeter width, and the organic sample is taken in a small glass tube and it is heated with fuming HNO3 and AgNO3. What happens over here on heating? The organic compound containing carbon would be converted to CO2, hydrogen would be converted to H2O, and the halogen would be converted into silver precipitate. That is the precipitate formation of AgX. Now, depending on the weight of the silver halide, we find the percentage of halogen by Carriers method. It's a simple calculation of percentage of halogen. So, the percentage of halogen is equal to the atomic weight of halogen upon the atomic weight of silver halide. Now, silver atomic mass is 108. So, silver halide would be 108 plus the atomic weight of the halogens. Now, the halogen could be fluorine, chlorine, bromine, iodine. So, if the atomic weight of halogens are not given, we are supposed to remember them. Fluorine molar mass or atomic mass is 19 gram per mole. Chlorine is 35.5 gram per mole. Bromine is around 80 and iodine is 127. So let's say the question is about the estimation of chlorine. So in that case, the formula would be atomic weight of chlorine, which is 35.5 upon atomic weight of silver chloride, which will be 108 plus 35.5, which is 143.5, into weight of silver halide upon weight of organic sample into 100. So it's a simple method of estimating the percentage of halogen. Now let's have a look at the example. In Carrier's method of estimation of halogen, 0.15 gram of an organic compound gave 0.12 gram of silver bromide. Find out the percentage of bromine in the organic compound. So now, to get the percentage of bromine, the formula was atomic weight of bromine, that is 80, upon atomic weight of silver bromide, which is 188, into weight of AgBr 0.12 upon weight of organic sample 0.15 into 100. So now, let's have a look at the solution. So molar mass of silver bromide is 108 plus 80, which is 188. 188 gram of AgBr contains 80 gram bromine. So 0.12 gram of AgBr would contain 80 into 0.12 upon 188 gram bromine. So this is how the actual method is, but the percentage of bromine could be finally directly calculated as 80 upon 188 into weight of AgBr upon weight of organic sample into 100. On doing the calculation, we get the answer as 34.04%. Next, estimating the percentage of sulfur. Now, even the sulfur is estimated by Carrier's method. The arrangement is similar, but now, along with fuming HNO3 and AgNO3, the sulfur containing compound produces sulfuric acid. Now that sulfuric acid is further reacted with barium chloride. The sulfur in the organic sample is converted to sulfuric acid and then it is further treated with BaCl2. So with the barium chloride, it forms a white precipitate of barium sulfate and twice of HCl. And as we know that barium sulfate precipitate is insoluble in any of the mineral acids, this precipitate could be washed, purified and then weighed, and as per the weight of barium sulfate we can determine the percentage of sulfur. So now the formula for percentage of sulfur would be the amount of sulfur present in barium sulfate into weight of barium sulfate upon weight of organic sample into 100. So it's a simple trick to remember. 32 grams of sulfur in 233 gram of barium sulfate into weight of barium sulfate upon weight of organic sample into 100. So the formulas are similar. The ratio is just dependent on the amount of element present in the reference compound. Now let's see the example. In sulfur estimation, 0.157 gram of an organic compound gave 0.4813 gram of barium sulfate. So what is the percentage of sulfur in the compound? Once again, the formula for percentage of sulfur using Carrier's method is 32 grams of sulfur in 233 grams of barium sulfate into weight of barium sulfate upon weight of organic sample into 100. So let's see the solution. The molecular mass of barium sulfate is 137 plus अच्छे से मतलब बेटा molecular mass of barium sulfate is 137 barium plus sulfur is 32 plus O4 would be 64. Totaling we get 233 grams per mole. Now 233 grams of barium sulfate contains 32 gram of sulfur. So 0.4813 gram barium sulfate would contain 32 times 0.4813 upon 233 gram of sulfur. So the percentage of sulfur would be 32 upon 233 into weight of barium sulfate upon weight of organic sample into 100. On doing the calculation we get 42.1%, that is approx around 42%. Next is the determination of element phosphorus, and phosphorus is determined by ignition method. Now ignition method is more or less similar to Carey's method. The main point over here is magnesium by ignition method is converted to magnesium pyrophosphate, having a formula Mg2P2O7. So now the reference compound for determining the percentage of phosphorus is Mg2P2O7, that is magnesium pyrophosphate. And now you can just understand the formula. The percentage of phosphorus would be the amount of phosphorus in 1 mole of Mg2P2O7 into the weight of Mg2P2O7 upon weight of organic sample into 100. Now the number of moles of phosphorus in 1 mole of Mg2P2O7 is 2 moles. It's P2. That is why there will be 62 gram of phosphorus in total molar mass of this is 222 grams. So 62 upon 222 into weight of this compound upon weight of organic sample into 100. So this is the formula. The percentage of phosphorus would be equal to 62 grams of phosphorus. Remember, it is 2 mole phosphorus. 62 grams of phosphorus upon 222 gram of Mg2P2O7 into the weight of Mg2P2O7 in the experiment upon weight of organic sample into 100. An example: 0.4 gram of an organic compound containing phosphorus gave. So this is the weight of organic compound and containing phosphorus gave 0.555 gram of Mg2P2O7 by usual analysis, and we have to calculate the percentage of phosphorus in the organic compound. So firstly, remember the molecular mass of Mg2P2O7. If you don't remember, then you can calculate the molar mass of Mg2P2O7 would be equal to 48 plus 62 plus 112, giving a total of 222 gram per mole. So now 222 gram of Mg2P2O7 contains 62 grams of phosphorus. So 0.555 gram of magnesium pyrophosphate would contain 62 into 0.555 upon 222 gram of phosphorus. So the percentage of phosphorus is equal to, the formula is simple, 62 gram of phosphorus into 62 grams of phosphorus in 222 gram of Mg2P2O7 into weight of Mg2P2O7 upon weight of organic sample into 100. On calculation, we get 38.75%. Next is the estimation of element oxygen. Now oxygen here is estimated by iodine method. A simple method to determine oxygen is to calculate the percentages of all other elements in the organic sample and then subtract it from 100. So one simple method would be percentage of oxygen is equal to 100 minus percentage of all other elements. This is one of the simplest method. The second method here is iodine method. So what is done in iodine method is the organic compound is heated in the atmosphere of nitrogen. On heating in the atmosphere of nitrogen, oxygen gas is released along with various other gases pertaining to other elements. Then this oxygen gas is passed over red hot coke and it is heated to a high temperature of 1337 Kelvin. At this temperature, carbon oxidizes partially into carbon monoxide, meaning the red hot coke is oxidized with oxygen to form 2 moles of carbon monoxide. Then this carbon monoxide is added with iodine pentoxide, which is a strong oxidizing agent, and here the carbon monoxide oxidizes to carbon dioxide and I2O5 reduces to I2. If I balance up the reaction, then 5 moles of carbon monoxide is oxidized with 1 mole of I2O5 to form 5 moles of carbon dioxide and 1 mole of iodine. So basically the determination of oxygen is done via conversion of this oxygen into carbon monoxide and this carbon monoxide then converted to carbon dioxide. So if I start from this oxygen, we can observe that we have 1 mole of oxygen and this 1 mole of oxygen is converted into 2 mole of carbon dioxide, and here the 5 moles of carbon monoxide is converted into 5 mole of carbon dioxide, meaning they are in the same proportion, same moles. So overall I can say that 1 mole of oxygen is converted to 2 moles of carbon monoxide, which is equivalent to 2 moles of carbon dioxide. So 32 grams of oxygen is converted to 88 gram of carbon dioxide. So through this relation and applying the unitary method, we can now find out the percentage of oxygen. So the formula is now simple. 32 gram oxygen present in 88 gram carbon dioxide into weight of carbon dioxide upon the weight of organic sample into 100. Now this 32 by 88 could also be written as 16 by 44. So finally we have the formula of percentage of oxygen as 16 gram of oxygen upon 44 gram of CO2 into weight of CO2 upon weight of organic sample into 100. So this is the iodine method for determining the percentage of oxygen. Next is the estimation of element nitrogen. And nitrogen is estimated by two important methods. The first method is Dumas method and the second method is Gildan method. Now let's see the apparatus of Dumas method. So in Dumas method, the carbon dioxide gas is passed through a series of copper oxide gauze. This copper oxide gauze allows the high temperature to be maintained. So the CO2 gas is passed through first the copper 2 oxide gauze, then it is further heated with copper oxide along with the organic compound to be tested, in which the nitrogen is to be estimated. So here, as we know that copper oxide would convert carbon into carbon dioxide, hydrogen would be oxidized into water, and the nitrogen present in the organic compound would be converted into N2 gas and not to its oxide. So here the nitrogen is converted into N2 gas, and in case the nitrogen is converted to its oxide in small proportion, then at the end we have a reduced copper gauze which would convert any of the nitrogen oxide into nitrogen gas. So finally the product from this copper gauze series is nitrogen gas. The other gases will be absorbed in this porous copper oxide. Now this nitrogen gas, which is highly heated gas, is passed through the mercury seal and it is collected over water. So this is the moist nitrogen which is collected above the water. The pressure associated with this nitrogen gas will not be the actual pressure of the pure nitrogen gas, because since it is collected over water, even the water vapor will exert some pressure. So the pressure of pure nitrogen would be actually equal to the total pressure of this moist nitrogen gas minus the pressure of the water vapor, and the pressure of the water vapor is called as aqueous tension, is referred as aqueous tension. So the total pressure which we get over here is to be subtracted from aqueous tension to get the pressure of the nitrogen gas. Now to determine the percentage of nitrogen, we need to have the volume of nitrogen gas at STP. But the volume which we get over here is not at the standard condition of temperature pressure, so we need to convert by using the ideal gas equation, that is the relation of PV upon T equal to constant, and through that the percentage of nitrogen could be determined. So let's see the concept and the calculation. So the organic compound containing nitrogen of the type CXHYNZ is oxidized with copper oxide in the presence of carbon dioxide. So carbon oxidizes to carbon dioxide, hydrogen oxidizes to water, and nitrogen would be separated as nitrogen gas. And any of the oxides, if at all formed, would be reduced via the reducing copper gauze back to nitrogen gas, and the copper oxide would be reduced into copper. Then, based on the volume of nitrogen determined at STP, the percentage of nitrogen is calculated as 28 upon 22,400 into volume of N2 at STP upon weight of organic sample into 100. In Dumas method, percentage of nitrogen is estimated as 28 upon 22,400 into volume of nitrogen at STP on weight of organic sample into 100. So it will be clear once we look at the example. So this is the example. In Dumas method, for estimation of nitrogen, 0.3 gram of an organic compound gave 50 ml of nitrogen collected at 300 Kelvin temperature and 715 mm pressure. Calculate the percentage composition of nitrogen in the compound, and the aqueous tension at 300 Kelvin is given as 15 mm. So now look at the data. The moist nitrogen which is collected over water has a pressure of 715 mm. So the pressure of pure nitrogen would be 715 mm minus aqueous tension, that is 15, which will be 700 mm. And to convert the volume of nitrogen at STP, we have to use PV upon T equal to constant relation. and then simply apply the formula. So let's look at the solution. Volume of nitrogen collected at 300 Kelvin and 715 mm pressure is 50 ml. So this is not the standard volume which is required. So actual pressure now is 715 of the moist nitrogen gas minus 15 the aqueous tension. So that will be equal to 700 mm. Now using the relation of P1 V1 upon T1 equal to P2 V2 upon T2, the volume of nitrogen at STP will be equal to the standard temperature 273 upon the standard pressure 760 into 700 into 50 upon 300, and on calculation we get 41.9 ml. So the relation which is used over here is P1 V1 upon T1 equal to P2 V2 upon T2. So let's say the subscript 1 refers to the standard condition. So the volume of nitrogen at STP would be equal to P2 V2 upon T2 into T1 upon P1. So if we talk about the non-standard condition, this is the pressure 700 mm into volume 50 ml upon temperature 300 into the standard temperature 273 upon the standard pressure 760. So this is a substitution, and on calculation we get 41.9 ml. Next, so this is how we got the formula. 22,400 ml of nitrogen gas at STP weighs 28 gram. We know that 1 mole of any gas at STP always weighs 1 mole of any gas at STP is equivalent to its molar mass and occupies a volume of 22.4 liter or 22,400 cm cube or ml at STP. So this is a relation 22,400 ml of nitrogen at STP is equivalent to 28 gram. So now the volume of N2 at STP, which is 41.9 ml of nitrogen, would weigh, just cross multiply 28 by 22,400 into 41.9 gram. So the percentage of nitrogen would be 28 by 22,400 into 41.9 upon the weight of organic sample, that is 0.3 into 100, and on calculation we get the answer as 17.46%. So two parts to this numerical. The first one is to convert the volume of nitrogen under non-standard into standard condition, and then using the standard relation of 1 mole of nitrogen equivalent to 28 gram occupying 22,400 ml, and then using the formula for the percentage of nitrogen. So this is Dumas method for estimating nitrogen. Now coming to the next method of estimation of nitrogen, that is Jain method. So now in Jain method, firstly we have a round bottom flask with a long neck which is called the Jain flask, and in this Jain flask we take organic compound and concentrated sulfuric acid and cupric sulfate. Organic compound plus concentrated H2SO4 and cupric sulfate. So in this Jain flask, the organic compound containing nitrogen is added with sulfuric acid and cupric sulfate. So the nitrogen present in the organic compound here is converted into ammonium sulfate, that is NH4 twice SO4. So now what we have over here in the Jain flask is ammonium sulfate. Now this particular ammonium sulfate is the content of Jain flask, and this content of Jain flask is now digested, meaning heated at a high temperature, and added with NaOH in this round bottom flask. So this is a different RB flask with a long neck called as Gildan's flask. The contents of Gildan flask are now transferred into this round bottom flask after digestion, meaning heating at a high temperature and then added with NaOH. So what happens over here is the ammonium sulfate, which is the content of Gildan flask, gets added with NaOH. So here the sodium combines with the sulfate to form sodium sulfate, plus the ammonium ion combines with the hydroxide and breaks down to give ammonia and H2O. So the main product of this RB flask is ammonia. So from this reaction we get the ammonia, which is trapped in the Gildan tube, which is called Gildan's trap. And since this is highly heated ammonia gas, it is cooled down by passing through a condenser. So this is a condenser through which the ammonia gas is cooled, and on cooling the liquid ammonia is collected in this conical flask and is titrated against a known volume of a standard acid, which is generally sulfuric acid. So the overall apparatus and working of Gildan's method is: first we take the organic compound containing nitrogen, whose estimation is to be done, added with sulfuric acid concentrated and cupric sulfate. In the Gildan's flask, we have the formation of ammonium sulfate. Then the contents of this Gildan's flask after digestion is transferred into this RP flask and added with NaOH. On addition with NaOH, it converts the ammonium sulfate into ammonia gas. Now this ammonia gas is trapped in this tube, which is called Gildan's trap, and finally cooled down and collected in the conical flask. And this ammonia, which is collected over here, is titrated against a known standard volume of the acid. So the Gildan's method, nitrogen containing compound is treated with concentrated H2SO4 to get ammonium sulfate, which liberates ammonia on treating with NaOH. Ammonia is absorbed in known volume of standard acid. So 3 points to be remembered. So after the titration of ammonia, which is released with the known acid, that is generally sulfuric acid, which is used, or it can be any other acid, the percentage of nitrogen could be estimated by a simple formula, which is 1.4 into the equivalence of acid used upon weight of organic sample. Remember, we don't use multiply by 100 to get the percentage of nitrogen over here, because the formula balances that 100, and finally we get a simple formula as 1.4 into what is equivalence of acid? It's molarity into volume into the basicity of acid. So it's molarity of acid into basicity of acid into volume of acid used upon the weight of organic sample. Now let's understand this with an example. During estimation of nitrogen present in an organic compound by Gildan's method, the ammonia evolved from 0.5 gram of the compound in Gildan's estimation of nitrogen neutralized 10 ml of 1 molar H2SO4. Find out the percentage of nitrogen in the compound. So simply, one part is the weight of the organic compound and another part the acid volume and the molarity is given. So now the calculation is simple. 1 molar of 10 ml H2SO4 will be equivalent to 1 molar of 20 ml ammonia. Why? Because sulfuric acid is a dibasic acid. So 10 ml sulfuric acid would be equivalent to 20 ml of ammonia. So 1000 ml of 1 molar ammonia contains 14 gram nitrogen. 20 ml of 1 molar ammonia would contain 14 by 1000 into 20 gram nitrogen. So finally, the percentage of nitrogen would be 14 by 1000 into 20 by 0.5 into 100. So if we see the calculation, this gets cancelled off. 14 by 10 becomes 1.4 into molarity of acid is 1 into basicity of acid is 2 because sulfuric acid is a dibasic acid into volume, that is 10, upon the weight of organic sample, that is 0.4, and hence on calculation we get the percentage of nitrogen equal to 56%. So the simple formula is 1.4 into equivalence of the acid upon weight of organic sample. Now let's discuss some more examples of Geldahl's method. A sample of 0.5 gram of an organic compound was treated according to Geldahl's method. The ammonia evolved was absorbed in 50 ml of 0.5 molar H2SO4. The residual acid required 60 ml of 0.5 molar solution of NaOH for neutralization. Find the percentage of nitrogen in the compound. So in Geldahl's method, the organic compound containing nitrogen is first treated with concentrated H2SO4 and CuSO4, and in the Geldahl's flask it is converted to ammonium sulfate. That ammonium sulfate is transferred to another RB round bottom flask containing NaOH, which converts the ammonium sulfate into ammonia, and the ammonia gas which is evolved is trapped in Geldahl's trap and then neutralized with NaOH. So the percentage of nitrogen could be found by a simple formula. Now this is a direct shortcut formula which you can use for any Geldahl's question, and without the lengthy method you can come to the answer directly. So let's see the solution. The direct formula is percentage of nitrogen as per Geldahl's method is 1.4 into molarity of acid into basicity of acid into V minus V1 upon basicity of acid upon weight of organic compound. Here we are not multiplying by 100, it is directly adjusted. So here this V is the total volume of acid which is absorbed in the Geldahl's method, the total volume of the acid absorbed, and V1 is the volume of NaOH required for complete neutralization. So the difference V minus V1 upon basicity of acid gives the volume of ammonia which is evolved, which in turn is equivalent to the volume of the acid which is used in the neutralization process. So finally the molarity of acid into basicity of acid into the actual volume used by ammonia would give the milliequivalents of the acid. So now substituting the values, going back to the question, this was the question. 0.5 gram is the weight of organic compound, 50 ml is the acid volume, the total acid volume, 60 ml is the base volume. So the difference will be taken as 50 minus 60 upon 2, which is 50 minus 30. This will be the volume of acid which is actually equivalent to the volume of the ammonia which is evolved as per the equivalence method. So the percentage of nitrogen would be 1.4 times 0.5 times 2 into 50 minus 60 by 2 upon 0.5. So this 0.5 gets cancelled off and the difference comes out to be 20, and the multiplication of 1.4 into 2 into 20 directly gives you 56%. Now here the acid which was in consideration was sulfuric acid. But if the acid is something else which has a basicity different from the sulfuric acid, then the similar formula needs to be used, only the basicity needs to be altered. So let's see one more question. 29.5 milligram of an organic compound containing nitrogen was digested according to Gilda's method, and the evolved ammonia was absorbed in 20 ml 0.1 molar HCl solution. The excess of the acid required 15 ml 0.1 molar NaOH solution for complete neutralization. Find the percentage of nitrogen in the compound. So as per the shortcut formula, the difference in the volume would be 20 minus 15 upon 1. Why 1? Because now the acid in consideration is a monobasic hydrochloric acid and rest of the solution remains the same. So now in the formula we'll substitute 1.4 into 0.1, which is a molarity of HCl, into 1, which is a basicity of HCl, into the difference is 20 minus 15 by 1, and divide by 29.5 into milligram needs to be converted into grams, so it's 10 raised to minus 3. So on calculation we get 1.4 into 100, 0.1 upon 10 raised to minus 3 gives you 100, into this difference gives you 5, and divide by 29.5. So overall we'll get 700 upon 29.5, which comes out to be 23.7%. So that's how we can solve the questions of Gilda's method in a very simple manner.